Okay, today we're going to continue with 10.2, which is solving multi-step equations, which is similar to what we did yesterday, but in today's lessons you're going to see fractions and combining like terms. Remember, like terms is when you have the same variable and the same exponent. So for example, we could say 5x and 2x are like terms because they both have the variable x, and there's an exponent here of 1. Another example is -3 and 8. Those are both like terms, so you could combine those together. Let's start with this first example of 8x plus 6 plus 3x minus 2 equals 37. So what we want to do is we want to make these equations look like they did from 10.1. So we're going to combine our like terms together. So I'm going to look for same variable and same exponent. So right away I see 8x and 3x are like terms, so I'm going to grab those and I'm going to put them together. And I'm just going to add them, so 8x plus 3x is going to be 11x. Then I'm also going to, I also see that 6 and -2 are like terms, and we should have done SAO here at the beginning. So I'm going to take both of those and I'm going to combine those together, and 6 plus -2 is a +4. So I'm going to bring that down, and then I'm going to say it equals 37. Now our equation looks just like it did yesterday, so we're going to solve it how we did yesterday. So whatever I do to the left side, I have to do to the right side. So I'm going to add a -4 to both sides so that it cancels out on the left. And then I'm left with 11x equals 33. Then I'm going to divide by 11 on both sides, and I get x equals 3. Now, just like yesterday, we can check our answer. So I'm going to go back to the very first equation that I see, or the one that was given, and I'm going to do 8 times 3 plus 6 plus 3 times 3 plus -2, and I want to know, does that equal 37? So order of operations says I have to do multiplication first, so 8 times 3 is 24. I'm going to bring that plus 6 down. 3 times 3 is 9 plus -2. Does that equal 37? So you can go ahead and check that in your calculator, and you should end up getting, so 24 plus 6 is 30, plus 9 is 39, minus 2 is 37, and 37 equals 37, so that checks out. Okay, so here's a new type of problem. We have 3y over 7 plus 5/7 equals -1/7. When you're dealing with fractions, you want to get rid of the fractions, so that way you're dealing with whole numbers. So what you're going to do is you want to find your least common denominator. So what that means is you are going to look at all of your denominators and see what do they all go into. In this problem, it's nice because every single one is 7, so your LCD here is 7. So what you're going to do is you're going to multiply everything in this equation by 7, or you can think of this as 7 over 1. So what you're going to do is we are going to distribute. So each term is going to be multiplied by 7. So think of this as 7 over 1 times 3y over 7. And then I'm going to do it to the second term. So plus 7 over 1 times 5 over 7 equals, and again take it all the way to the back, 7 over 1 times -1 over 7. So now all I want to do is I want to look at this term. And notice I have 7 on a numerator and denominator, so they cancel out. So I'm left with 3y plus. Now if I look at this second term, the same thing happens. So I'm left with plus 5 equals, and again on this last one, the same thing happens, so -1. Now you're just back to what you were doing before in solving for y. So go ahead and pause it and see if you can solve for y on your own. Okay, what you should have done is subtract or added a -5 to both sides to make this 3y equals -6. Divide by 3. So y equals, now remember, a negative divided by a positive is going to be a negative. So our answer is -2. And you can always go back to your original and check your answer. Okay, let's try this last example. It says 2p over 3 plus p over 4 plus -1/6 equals 7 over 2. So remember how I said in the last example we got to find an LCD. The last one, it was nice because every denominator was the same number. In this problem, it's not going to be so easy because all of our denominators are equal, or are different. So we need to find a number that 3, 4, 6, and 2 go into. So let's think of some multiples of 2. Well, you have 2, 4. 6 and 3 can't go into that. The next multiple is 6, but 4 cannot go into 6. Then we have 8. 3 and 6 cannot go into 8. Then we have 10. Those 3 cannot go into it. 12. All right, 12. 12, all of those numbers can go into. So our LCD is 12. So we are going to multiply this whole thing by 12 over 1. So remember, that means we are going to have to distribute it and take it to every term. So we're going to do 12 over 1 times 2p over 3 plus 12 over 1 times p over 4 plus 12 over 1 times -1 over 6 equals 12 over 1 times 7 over 2. So now let's just simplify those terms out. I'm going to start with this first one here. 3 goes into 12 4 times, so I can change that to 4 and my 3 to 1. 4 times 2p is 8p. So my denominators go away. See if you can change the last 3 on your own. Okay, what you should have done is 4 goes into 12 3 times. So this becomes plus 3p. Over here, if I look at the next one, 6 goes into 12 2 times. So I get plus -2. And then finally at the end, 2 goes into 12 6 times. 6 times 7 is 42, so this equals 42. Now this is kind of like the first example that we saw. This is actually very similar. We need to take our like terms and combine them together. So my like terms are 8p and 3p. When I add those together, I get 11p plus -2 equals 42. Go ahead and pause the video, see if you can solve it from here on your own, then check your answer to mine. Alright, I'm going to add 2 to both sides, and I get 11p equals 44. I'm going to divide by 11, so p equals 4. And again, you can check your answer. Alright, I know that there was a lot of examples, but use these to help you on the exit slip, and you can go ahead and get started on that now.